Okay, this video is going to show you how to do a restriction map for a linear piece of DNA. I'm pulling this from problem 4 from the AGP. For this one, when you are you're drawing out the electrophoresis, the bands for it. At the top, you're going to label what each of the wells were. So for these first three, I have each of the three restriction enzymes that we're using, BAM, ECO, and HIND. And then the next three are the combinations. So we have BE, which is BAM and ECO, BH, BAM and HIND, and then H and E, which is HIND and ECO. On the left, going down, you're doing the lengths of the DNA. So the piece of DNA that they were using in this problem was the 900 base pairs long, and so we're going to go in 100 increments. So for BAM, as you see, I'm putting in here, there were three sections of the DNA when it was split up. So we had a 500, a 350, and a 50. For the ECO, there were two pieces. One was 700 and one was 200. And then for HIND, we had a piece that was 600 and one that was 300. And when you tally each of those up in their own well, they should add up to 900. Okay, when we have the combination of BAM and ECO, we have a piece that is 500, one that's 200, one that's 150, and one that's 50. For BAM and HIND, we have a 500 piece, a 250 piece, a 100, and a 50. And then for HIND and ECO, we have a 600 piece, a 200 piece, and a 100 piece. Okay, so now you want to do a map. What I like to do is take each of the three restriction enzymes and write them out, and then I draw a line that represents the full length of the linear DNA so I can have a visual of what it would look like when they get chopped up by the enzyme. So up here for BAM, there's three pieces. There's a small 50 piece, there's a medium 350, and then there's a 500 piece. These could be in different orders. It doesn't necessarily have to be in the smallest to largest. We don't really know, but you just kind of have to mix around with it sometimes. The best strategy that I have for it is to choose whatever is the largest piece. So for BAM, the largest piece was 500, and I put that on one side of the full piece of DNA. And all the remaining ones, I look like the ECO and the HIND, I look for the largest piece, which is the 700 and the 600 respectively, and I keep those all in the same part of the DNA. So all three of them, I put the largest piece on the far right. Here I'm just kind of giving a visual. What you do is, like for ECO, you look down and you saw the 700 and you make sure that 700 piece there and the 200. HIND, I see the 600 and the 300. So at the beginning when you're doing this, the order could vary. So for example, for the HIND at the bottom, you could have had the 600 on the left side and the 300 on the right side and move that orange mark. So it's kind of a trial and error process. The easiest way, again, like I said, is to put all the largest fragments from each of the restriction digests and put them on one side of the linear DNA. So the next step is to map out the double digest, so where you have, for example, BAM and ECO, BAM and HIND, or HIND and ECO, and take the marks from above with the single digests and start to bring them together. So for example, I'm going to start here with at the bottom with the HIND and ECO because each of those only have one cut that each of them make. So we'll start with the ECO mark, which is in purple, and I'm going to put that down first on this. So mark off, which would be 20 and then, or 200 and 700. And then I'm going to bring down the HIND mark right there. And that would be 300 and 600, but now that first segment is also broken up by the ECO. So now we kind of do the math and figure out. So on the right, that's still going to be a 600 piece, but now we break up this 300 between 200 with the ECO mark and then the remaining 100. So then we can check our map with the electrophoresis, that last column that we have there. And we see that in the column there's a 600 mark, which on the map we have a 600 size fragment. We have a 200 size fragment in the column, and the same thing on our map, and a 100 size fragment, which we also have on our map. So right now this looks good. So just for clarification, I'm going to give you an example of when the map doesn't work. So we're going to do the same thing, the HIND and the ECO, and first I'm going to make the mark with the HIND where we break up the 300 segment and the 600, but now I'm going to break up with the ECO mark, and instead of putting it right there where I typically was, I'm going to go the opposite direction and mark off the 200 that way. This would still make a 200 segment and technically a 700 segment that now has the HIND mark in there too. The Hind restriction enzyme breaks up that 700 piece into a 300 and a 400 piece, and now our entire map has a 300, a 400, and 200 piece. As you can see, I pointed really quickly, but if you compare now the map to the gel, we can see that while there is still a 200 fragment in both the map and the gel, the map does not have a 700 fragment like we can see, and it does not have a 100 fragment, so we can tell that this way that we set it up is not the correct way that the map lays out. So this is just an example of when you can find out if you're mapping it incorrectly. And again, it's just a trial and error process. Okay, so now let's do the other double digest. So for BAM and Hind, we do the same thing. We're going to bring down the two BAM marks, which are in green. That's our 50, our 350, and our 500 segments that it makes. And then we're going to bring down the one orange Hind mark. And that is breaking up our 350 piece. So we know on the far right we have 500. We know that at the top here on the far left we have the 50, and then our 350 is broken up. So we are breaking it by 300 and then another 50 off. So we have 250. And then the remaining part is going to be 100. And again, we can go and compare. So we have a 500 fragment, we have a 250 fragment, a 100, and a 50. So we know that this map is good. Okay, so for our third double digest, we are bringing down the BAM marks. So we have our 50, our 350, and our 500. And then we're bringing down our eco mark, which is breaking up that 350 again. So we have our 500 on the far right, we have our 50 on the far left, and then our 350 is getting broken up, so there's 200 minus the 50, so we have 150 there, and then we have the remaining segment, which is 200. And then we check here, so we have a 500, a 200, a 150, and a 50, so this one looks good. Okay, so the final step is to bring all three of the restriction enzymes together. So we're going to make a new map that combines them all. And first I'm going to, in green, put the BAM marks. Then I'm going to add the eco mark there in purple, and the Hind mark there in orange. And then I'm going to see what these fragment sizes would be. So the largest one we know is 500, and that small one on the far left is 50. And then we know from this map that we have the 150, this one's going to be 100, and that last segment is also going to be 100. So you just kind of look at the previous maps that you make in order to figure out what the final map is going to be with all of the restriction enzymes. And then it's important when you have your final map that you go through and you label what each of the marks are. And again, you should label more that I'm doing, more than just the letters. So using this final map that we made, now we can create what would be, if we made a third well that had all three of those restriction enzymes in it, we can show what the DNA fragments would be if we use those. So there's going to be a 500 fragment, which we're going to mark right there. There's going to be a 150 fragment. And then there are two 100 fragments, so that's going to be right there, and sometimes you can draw that band a little bit thicker to show that there are two of them, or more than just one, and then our final one is a 50 fragment. So here we have what the final fragments would be from the complete digest. So I hope this video helps a little bit as you go through the process of making a linear restriction map. It's not like a cut and dry process, it's kind of like problem solving, putting together a puzzle. So it takes a little bit of practice and a little bit of trial and error, but this can kind of give you a direction to go. Alright, good luck studying!